slippery. It's very interesting. You say, how does it work? You could either say, I'm satisfied that you've answered me, ice is slippery, that explains it. Or you could go on and say, why is ice slippery? And then you're involved with something, because there aren't many things as slippery as ice. It's very hard to get greasy stuff, but that's sort of wet and slimy. But a solid that's so slippery, because it is in the case of ice that when you stand on it, they say, momentarily the pressure melts the ice a little bit, so you got a sort of instantaneous water surface on which you're slipping. Why on ice and not on other things? Because ice expands water expands when it freezes, so the pressure tries to undo the expansion and melts it. It's capable of melting it. But other substances contract when they're freezing, and when you push them, they're just satisfied to be solid. Why does water expand when it freezes and other substances don't expand when they freeze? All right? I'm not answering your question, but I'm telling you how difficult a why question is. You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. You'll notice in this example that the more I ask why, it gets interesting after a while. That's my idea, that the deeper a thing is, the more interesting it is. And we could even go further and say, why did she fall down when she slipped? That has to do with gravity, involved in all the planets and everything else. Never mind, it goes on and on. Now when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person who doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel, and that you're feeling that force.